Hey guys, in this video, I'm going to show you how to solve simultaneous equations. In particular, we're going to look at linear equations and we're going to go through the two different methods, so substitution and elimination. Then we're going to have a look at nonlinear equations and how to solve those. And then we're going to finish off with some 3 variable simultaneous equations. Okay, so let's start off with this first equation over here. So the first thing that I like to do is I like to write the 2 equations on top of each other. So I like to write them in like a vertical fashion. And I also like to label them. So equation 1 and equation 2. The elimination method basically calls on you to eliminate one of the variables, either through addition or subtraction. So what you need to do is first you need to identify, okay, what variable are you going to eliminate? And then what are you going to do to eliminate that variable? So in this case, the easiest variable to eliminate would be the y. And the reason is because the coefficients are the same in both equations. Since both the coefficients are positive, in order to eliminate them, we need to subtract them from each other. And so what that means then is we need to subtract the 2 equations from each other. So 2x minus x gives you x. 3y minus 3y gives you 0. And negative 14 minus 4. I'm going to write it out like this so you don't mix it up. So negative 14 minus 4, right? That gives you negative 14 plus 4, which gives you negative 10. And on the left-hand side, you're just left with x. So x equals negative 10. So that's the value of x. Now we need to find the value of y. So in order to find the value of y, so you sub x equals negative 10 into either equation 1 or equation 2. It's completely up to you. In this case, I'm going to substitute it into equation 2. So subbing negative 10 into equation 2 gives me negative 10 plus 3y equals negative 4. And then we solve this like a normal equation. So I'm going to add 10 to both sides. So plus 10 gives me 3y equals 6 because these cancel. And then dividing 3 to both sides, we get y equals 2. And then we have it. So that's the value of x and that's the value of y, negative 10 and 2. Okay, let's look at this next example where the coefficients are not the same. So once again, we're going to choose the variable that we want to eliminate. In this case, you can either choose k or h. It really doesn't matter. I'm just going to go for k. So if I want to eliminate the variable of k, I need to change their coefficients so that they are the same. And so the easiest number to change them to would be 6. That is because I can multiply this by 2 to get 6, and I can multiply this by 3 to get 6. So what's important though is that you multiply every single term by that factor. So let me show you how it's done. So we're going to take equation 1 and we're going to multiply it by 2. So you take the first term 3k, timesing that by 2 you get 6k. Then you take 2h, you multiply that by 2 you get negative 4h. And then you have negative 14, multiplying that by 2 gives you negative 28. Now this becomes a new equation, we're going to call it equation 3. The next thing we're going to do is then multiply equation 2 by a factor of 3. So we say 2 times 3. So 2k times 3 gives you 6k, negative 5h times 3 gives you negative 15h, and negative 13 times 3 gives you negative 39. And this will be called equation 4. Now that both the coefficients are the same, we can then either add or subtract these equations. And so obviously because they are both positive, in order to eliminate them, we need to subtract the 2 equations. So we're going to subtract. So we're going to do equation 3 minus equation 4. So 6k minus 6k gives you 0. Minus 4h minus 15 is like saying, I'm going to do it on the side here. It's like saying minus 4 and then you've got the minus 15. So the minus and minus here kind of cancel to give you a positive 15. And the negative 4 plus 15 is 11. So this becomes positive 11h. And then on the right hand side, we have negative 28 minus 39. The minus and minus cancel to give you a positive. And so you have negative 28 plus 39, which gives you 11. So then it's 11 on the right-hand side. And then finally, we divide 11 by both sides to get h equals 1. So there's the value of h. The last thing we need to do is find the value of k. So we can sub in this value of h into either of those initial equations. either equation 1 or equation 2. I'm just going to choose equation 1. So then we say sub h equals 1 into equation 1. So if you recall what equation 1 was, it's 3k minus 2h equals negative 14. So 3k stays. Now it's minus 2h. So it's minus 2 times h, which is 1, equals negative 14. I'm just going to expand that bracket there. And then we're going to add 2 to both sides. So we get 3k equals negative 12. We divide 3 to both sides. And so we get k equals negative 4. And there you have it. Those are the two solutions. So h equals 1 and k equals negative 4. So that was the elimination method. Let's have a look at the substitution method. So whenever you're doing the substitution method, you need to rearrange one of the equations to make either variable the subject. It doesn't matter which variable, you just have to make one of them the subject. So if you have these two equations over here, you need to take one of those equations and make something the subject. So the easiest equation to take would be this one. And I'm going to make y the subject of this equation. You could have made x the subject, it doesn't matter, but it's the easiest, but in this case, the easiest thing to do would be to make y the subject. So I'm just going to write the equation here, 5x minus y equals 19. So if I want to get y on its own, I need to minus 5x to both sides. So I get negative y equals 19 minus 5x. And I need to divide by this negative 1. Make sure you divide every term by that negative 1. So you get y equals negative 19 plus 5x. So this becomes my equation 1. And that's the equation that I'm going to substitute into this second equation. So if I write 2x plus 5y equals negative 14 as equation 2, then we can basically say sub 1 into 2. So all you need to do is wherever you see y in equation 2, substitute it with this value over here because that is the value of y. So let me show you how it's done. So we start with 2x plus 5 lots of y, and y we said is this value over here, negative 19 plus 5x. And that equals negative 14. Now what you've done is you've made an equation with only one variable, and so you can solve this like you normally would. So we're going to expand the brackets. So 5 times negative 19 is negative 95. And then 5 times 5x is positive 25x. That equals negative 14. I'm going to add these two like terms together to give me 27x minus 95 equals negative 14. And then I'm going to add 95 to both sides. So I get 27x equals 95 minus 14 is 81. And then finally, we're going to divide both sides by 27 to give you x equals 3. So that's the value of x. The last thing we need to do is find the value of y. So all we need to do is sub x equals 3 into this equation over here, this one, equation 1, because y is already the subject. So we're going to sub it into equation 1. So y equals negative 19 plus 5x, and x is 3. So that's negative 19 plus 15, which is negative 4. And those are the two values. Okay, let's look at this next equation here. Now this question is slightly easier than the previous one because, as you can see, you already have a variable as the subject of both equations actually. So what we're going to do is we're going to sub equation 1 into 2. So simply, if you take equation 2, the left-hand side says y. And because we're subbing equation 1 into that, we're going to replace that y with 3x minus 1. And then we're going to carry on with the right-hand side as it's written because there's no y there. And so it's just basically the same. Now we solve this like a normal equation. So we're going to try and get the x's together. So I'm going to subtract 2x to both sides. So you get 3x minus 2x is x. You're still left with minus 1. These cancel, and so you're left with 5. And then you're going to add 1 to both sides. These cancel, leaving you with 5 plus 1, which is 6. So that's the value of x. Next, we're going to find the value of y. So we're going to sub x equals 6 into equation 1. So equation 1 is y equals 3x minus 1. But x has a value of 6. So we're going to say 3 lots of 6 minus 1. So that's 18 minus 1, which is 17. And so y equals 17, and there's your solution right there. So this example was fairly straightforward. Okay, so let's have a look at nonlinear equations. And these are nonlinear equations because, you have x times y as opposed to x plus y and so forth. So the best way I would say to go about nonlinear equations is to use the substitution method. That's usually the best way, and most of the time it gets you to the right answer. So what we're going to do is we're going to make x or y the subject of either of those equations. Now I'm going to choose equation 1. So I'm going to choose to rearrange 1. So currently 1 reads as x times y equals 6. So I'm going to make y the subject. So I'm going to divide both sides by x so that I can get y on its own. So you get y equals 6 over x. Now this becomes equation 3. Then what I'm going to do is I'm going to sub equation 3 into my second equation. So what that means is wherever you see y in your second equation, you replace it with this value of 6 over x. So let's have a look at a second equation. So it reads as x plus y. So there's a y there, so I'm going to replace it with 6 over x equals 5. Now it's been reduced to one variable, so now we can solve it. The easiest way to solve an equation like this when you have x in the denominator is to multiply every term by that denominator. So we're going to multiply every term by x. So then x times x gives you x squared. Now 6 over x times x, these cancel to give you 6, and 5 times x gives you 5x. Okay, I'm going to move 5x to the other side. So I'm going to get x squared minus 5x plus 6 equals 0. Now what I have is a quadratic. So I'm going to have to solve this like I normally would with any quadratic. I'm going to factorize these. So I'm going to pop x in each bracket, and I'm going to split up 6 into 3 and 2, -3 and -2 to give me -5. And therefore you have two solutions, x equals 3 and x equals 2. Now, what you notice is we have two values of x. Normally we would have one value of x, but that's fine. If you have two values of x, then that means you should also have two values of y, ideally. So what we're going to do is we're going to take one value at a time. We're going to say that, okay, when x equals 3, what is the value of y? So if you want to find the value of y when x equals 3, substitute it back into equation 3. So we're going to sub x equals 3 into equation 3. So equation 3 reads as y equals 6 over x, and x is 3. So that reduces to 2. So when x equals 3, y equals 2. What about when x equals 2? The other case, we're going to do the same thing. We're going to sub x equals 2 into equation 3. So we're going to get y equals 6 over 2. That gives us 3. And that gives us our second solution for y. So then we can say that when x equals 3, y equals 2. So that would be one set. Then we can say that when x equals 2, y equals 3. That would be our second set of solutions. Okay, we're going to do this next example here, which is a little bit trickier than the first one, but we're going to do the same thing. We're going to use the substitution method, and we're going to make a variable the subject of one of these equations. The easiest equation to choose is obviously equation 2. Equation 1 is possible, but when you have squared, it kind of complicates things a little bit. So we're going to focus on equation 2, and we're going to focus on making y the subject again. You can make x the subject, but I'm just going to make y the subject. So we have 3x minus 4y minus 20 equals 0. So in order to make y the subject, we want to get it on its own. So then I'm going to minus 3x to both sides, and I'm also going to add 20 to both sides. So these cancel, leaving me with minus 4y. These cancel, and then the right-hand side just becomes minus 3x plus 20. Okay, now the last thing we've got to do is divide everything by -4. So these cancel. I'm left with y equals, now -3 over -4 is 3 over 4x, and 20 over -4 is -5. So this now becomes my equation 3. So now I'm going to sub equation 3 into equation 1. Okay, so equation 1 reads as x squared plus y squared, and we know that y has this value over here. So we're going to use a bracket, and we're going to substitute the y value in as 3 over 4x minus 5, and we're going to square that because that's being squared up there. we're going to say equals 16. Now it's a matter of algebra. And that's what I think makes this question a little bit tricky. So what I'm going to do is I'm going to take you through the steps that you need to basically solve this equation. The first thing you need to do is get rid of these brackets. Means you need to square what's inside. So whenever you want to expand a perfect square, like in this case, you square the first term. So 3 over 4x squared gives you 9 over 16x squared. You square that number to give you 9, you square this number to give you 16, and you square x to give you x squared. Then you multiply these two numbers together. I'm just going to write it on the side to show you. So 3 over 4x times negative 5, you multiply those numbers together. Now, and then this is just a matter of fractions. So you do 3x times negative 5 gives you negative 15x. 4 times 1 gives you 4. So we multiply those two together and we have to double it now. Doubling this, these can reduce to 1 and 2. And so you're just left with minus 15x over 2. And so the next term is minus 15x over 2. And then finally, you square the final term. The square of negative 5 is positive 25. Now let's collect these like terms. So we have x squared plus 9 over 16x squared. So that's kind of like 1x squared plus 9 over 16x squared. They're like terms, meaning that you can add these coefficients together. So the easiest way to do it is on the calc. So just do 1 plus 9 over 16. So that gives you 25 over 16. So 25x squared over 16. Minus 15x over 2, there's no like terms with that. What we want to do is want to bring this 16 over. So I'm just going to minus 16 to both sides. So I get 25 minus 16 is a positive 9. And this is 0 on the right hand side. So once again, we have a quadratic. There's a few ways to go about this. Personally, I don't like solving quadratics with fractions because it's a little bit more, it's a little bit harder to understand. And I feel like there is a greater chance of you making an error. So what I like to do, I try to kind of remove the fractions as best as I can. So in this case, in order to remove both of these fractions, you need to multiply every term by 16 because that's like the lowest common factor. So these 16s cancel, leaving you with 25x squared. This 2 reduces with the 16 to give you 8. So you're left with 8 times 15. So that's negative 120x. And then 9 times 16 is 144. And this is just 0. I know these numbers are really large, but I feel like it's a lot easier to work with whole numbers than it is to work with fractions. So in order to solve this quadratic equation, I'm going to use a quadratic formula. So x equals negative b, so it's negative 120, so that's a positive 120, plus or minus the square root of b squared, so 120 squared, minus 4, a, which is 25, c, which is 144. And that's all over 2a, 2 lots of 25. I'm going to clean what's underneath the surd. So I'm going to put everything that's underneath the surd into my calculator. So I'm going to put, negative 120 squared minus 4 times 25. And I'm literally just going to put it in as it's written on the page. So that gives me 0 there. And then 2 times 25 at the bottom gives me 50. So obviously the square root of 0 is 0. So this just becomes 120 over 50. And simplifying that, you get 12 over 5. There you go. So we just found the value of x. So x equals 12 over 5. And normally with a quadratic, you expect 2 values of x. But in this case, obviously we only have one solution, which is still possible. So now that we have the value of x, we need to find the value of y. So we go back. And how are we going to find the value of y? We're going to use our third equation. We're going to sub that value of x in to find the value of y. So I'm going to rewrite this equation down below. So that was equation 3. And I'm going to sub x equals 12 over 5 into equation 3. So y equals 3 over 4 times x. We said x is 12 over 5 minus 5. These can cancel to give you 3 at the top. Then you have left with 3 times 3 at the top, 9. 1 times 5 is 5 minus 5 minus 16 over 5. And that's the value of y. If you have trouble doing any of this stuff, I would just recommend pop it in the calculator. I'm not worrying too much about that. But I mean, this is a fairly basic level of reducing fractions, so you should have a basic understanding of how to do this. but in case I went too quickly, you can pop in the calculator. So there we have it. Those are the two solutions of X and the two solutions of Y. If you're ever doing this and you're unsure as to whether or not you got the right answer, you went about it the right way, the best way to check is to substitute those values into the original equations to see if it actually works. So I'm going to do that. I'm going to show you what I mean. I'm going to do that on the side here. I'm going to say check answer. So remember we got X equals, and we got Y equals negative 16 on 5. Okay. So we're going to sub those values into the first equation to see if it works. So it reads as X squared, so 12 over 5 squared, plus Y squared, and Y was negative 16 over 5 squared. That should equal 16. So let's see what we get on the left-hand side when we put that into our calculator. So when you put that in your calculator, you get 16, which equals the right-hand side and therefore satisfies this equation. And then you can sub in those values into equation 2 to make sure that it also works for equation 2. So we're going to say sub into 2. So this is not part of your solution. This is just a way of checking your answer. So we're going to sub in those values. So on the left-hand side, we have 3 lots of X, and X is 12 over 5, minus 4 lots of Y, which is negative 16 over 5, minus 20. So we put that in our calculator and we get 0, which satisfies the right-hand side. And therefore you can conclude quite confidently that these are in fact the solutions to this equation. Okay, so let's finish off with 3 variable equations. Now, 3 variable equations are a little bit trickier, but we're going to follow through with the same steps, either substitution or elimination. And obviously when we have 3 variables, we need 3 equations. That's why we now have 3 equations and not 2 equations, because with 2 equations, we would not be able to work it out. Okay, so with 3 variable equations, the first thing I like to do is I like to hone in on 2 equations at a time. And in those 2 equations, I like to eliminate 1 variable. So let's first focus on equation 1 and equation 2. What variable can we eliminate? Well, we can eliminate A by subtracting the equations, but we can also eliminate C. Because they have the same coefficient of 1, we can eliminate them by actually adding them together, because 1 plus minus 1 is 1 minus 1, which gives us 0. So that will also enable us to eliminate them. So what we're going to do is we're going to start with equation 1 and equation 2, and we're going to eliminate the variable of C. And I choose C and not A because I look at my third equation and I also realize that C has a coefficient of 1 in the third equation. So I'm like, okay, I know that C is going to be the easiest variable to eliminate. So I do equation 1 plus equation 2, right? Because I wanted to eliminate C, so I need to add them together. So that means A plus A gives me 2A, minus B plus 2B gives me positive B, and C plus minus C, which is C minus C, is 0. On the right-hand side, we have 7 plus minus 4 is 7 minus 4, which is 3. So this is 2A plus B equals 3. So this is now equation 4. You can see now that we've eliminated a variable, it's simplified it for us. The next thing you want to focus on is another pair of equations. So equation 2 and equation 3. So in a similar way, we want to eliminate the variable C. So in order to eliminate -1 and -1, we need to subtract these 2 equations. Because they have the same sign, we need to subtract them. Because what happens is you have -1 and this minus and minus cancel to give you a positive, which allows you to cancel them. So we're going to do equation 2 minus equation 3. So A minus 3A is minus 2A. Positive 2B minus minus B, right? Positive 2B minus minus B is 2B plus B, which is 3B. And we established before minus C minus minus C gives us 0. Minus 4 minus 3 gives us -7. So this becomes minus 2A plus 3B equals -7. This is now equation 5. Okay, so now you can see we have 2 equations with 2 variables. So now, like what we did when we had linear equations, we're going to try and now eliminate another variable. So looking at those 2 equations, we look at, okay, what variables have the same coefficients? And obviously A has the same coefficient, 2 and 2. So because it's a 2 and a -2, we just simply need to add them to cancel them out. So what we're going to do is we're going to say, and I'm going to work up here just because it's getting a bit long, going to say equation 4 plus equation 5. So we have 2a plus minus 2a is 0. b plus 3b gives you 4b. And 3 plus minus 7 gives you minus 4. Dividing both sides by 4 to find b, we get -1. Okay? Now we need to find a. So we're going to sub the value of b into any one of these equations over here. So equation 4 or 5. So I'm going to say sub b equals -1 into equation 4. So we have 2a plus b, so -1 equals 3. I'm going to add 1 to both sides. So you get 2a equals 4. Divide 2 to both sides, you get a equals 2. And there's the value of a. So we're almost there. So we got the value of a. So I'm going to write it up here. So the value of a is 2. We got the value of b is -1. The last thing we need to find is the value of c. So now that you have 2 of these variables, you can now use one of these equations. So I'm going to use equation 1 because it's the simplest of them all. So I'm going to say sub a equals 2, b equals -1 into equation 1. So equation 1 is a minus b plus c equals 7. So I'm going to sub in a, so 2. I'm going to sub in b, so minus 1 plus c equals 7. And now we can solve for c. So I'm going to kind of simplify this. So negative times a negative gives you a positive. 2 plus 1 is obviously 3. So this is 3 plus c equals 7. And then we're going to minus 3 to both sides. So those cancel to give us 7 minus 3, which is 4. And there's the value of c. And then we have it. That's a 3-variable equation. These usually require more work than your standard 2-variable equation, obviously, because there's 3 variables now to find. But the best way to do this is eliminate one of the variables so that now you have 2 equations with 2 of the same variables, and then you follow through as you normally would with your normal 2-variable equations. Anyways, I hope you found this video helpful. If you have any questions, leave them down below. I'll see you in the next one.